Question 4. Describe fully the single transformation which maps triangle P onto triangle Q. Now, this transformation should be obvious by looking at the sizes of these. This triangle has been made bigger to make triangle Q. This would also apply for smaller. Both of them are known as an enlargement. So the first mark here is for quoting an enlargement. Now there's two things that we need to then comment on in order to get the full marks for this. One of them is the scale factor. So in other words, how much times bigger our new shape is compared to the old shape. We can get this just by counting the squares or counting the length of one of the sides. So as I'm highlighting here, that shape P has a height of 2 and this shape Q has a height of 6. So our scale factor will be 6 divided by 2 for 3. So the second mark for this is for stating that we have a scale factor. I say for scale factor, I should really be writing of enlargement of scale factor 3. Last thing we have to do is identify where the center of enlargement is. Now, there's more than one way of doing this. Probably the simplest way, as you're able to draw on the page, would be to draw a straight line passing through corresponding corners of the shape. So for example, the top of each of those triangles I've highlighted in navy blue there. The bottom left of each of these triangles I've highlighted in royal blue, and we'll go with green for the bottom right hand corner, like so. If you draw straight lines going through those two corners, and if you continue going in this direction, basically beyond the smaller shape, all three of these lines will intersect at the same point. And I'm going to draw that for you now. So these are all going to intersect. You can see already where two of them intersect, and no coincidence, all three of them intersect there. So this here, actually I'll do it in red, this here is our center of enlargement. So we would just say enlargement of scale factor or by scale factor 3 with center, and then quote the coordinates of that red point, which is 4, 3. So 4, 3. Part B. On the grid, translate the triangle Q, so that's this one here, by the vector -8, 2. So what I'm going to do is I'm just going to erase everything that we did in part A, just so we've got a nice fresh page here. Translation means that we are effectively moving shape Q, and we're moving it by 8 to the left and 2 up. So the negative on the top tells us we're going left. So we're going to go left 8 and we're going to go up 2. Now how we do this is pick any corner and move it 8 to the left and 2 up. If we do that, we're going to end up here. Technically, we can now just redraw our triangle, or if you want a little bit of insurance, then we can pick another corner and translate or move 8 to the left and 2 up, like so. And if I want extra insurance, then I can do the same with the third corner. After that, we simply then need to join the dots or redraw that triangle like so. That'll be a little bit wonky at the end there. No, I didn't want to play ball. But yeah, you should have a shape that looks exactly the same size as the other one. It says label your triangle, your new triangle R, so I'm going to do that now. And then lastly, part C. Describe fully the single transformation which maps triangle R onto P. So R onto P, that's this R is going to go onto P. So the fact that they're different sizes of different sizes means that we're going to be doing enlargement, but enlargement also includes when you make something smaller. Our triangle R is definitely bigger than our triangle P, and a clue for how we go about this is it's going to be kind of the opposite of the enlargement we had in part A. Part A involved a scale factor of 3, making this triangle 3 times as big, but now we kind of want to make this triangle 3 times as small, which you wouldn't say 3 times as small. What you would say is that you are going to enlarge it by a scale factor of 1/3. So it's 1/3 as big as it was before. Now, of course, we've got to find that center of enlargement again. So I'm going to do exactly the same setup as before. It doesn't matter if the shape's getting bigger or smaller. You're going to connect the corresponding corners here with a straight line, and then extend it and see where they all meet. So doing that just now with these, straight away I can see where our center of enlargement is. It's right here. So 8, 2 is going to be our center of enlargement. And that's it. Done.